Hello everyone, my name is Philip Mack and I'm a PhD student at the University of Guelph. And in collaboration with Agriculture and Agri-Foods Canada, I will be presenting data from bacteriological analysis of cecal samples from broiler chickens reared on commercial gut health management programs. One of the major challenges in Canadian poultry production is antibiotic use and antibiotic resistance. According to the Canadian Integrated Program for Antimicrobial Resistance Surveillance, or the CPARS report, 78% of all antimicrobials sold and distributed in Canada were solely used in the food animal sector. The Chicken Farmers of Canada, or CFC, created a policy to eliminate the preventative use of Category 1, 2, and 3 antibiotics as ranked by Health Canada in broiler production as of 2021 to combat antimicrobial resistance. This means antibiotics such as bacitracin for the preventative use of necrotic enteritis were not used in broiler production, posing a health threat to chickens. However, the ongoing research for antibiotic alternatives do show promise. Antibiotic-resistant bacteria have been reported in commercial poultry production, posing a threat to humans through the transfer of antibiotic resistance. Moreover, the resistance mechanisms of both gram-positive and gram-negative bacteria against antibiotics are vast and unique, making it difficult to combat. Reducing antibiotic usage is one of the primary methods to reduce AMR. So my study investigates the effect of different feeding programs on the antimicrobial resistance profiles of broiler chickens. A total of 2,304 day-old Ross broiler chicks were allocated to 3 different feeding programs. Conventional feeding program fed a basal diet with bacitracin and avilamycin, also known as conventional or con. A basal diet supplemented with avilamycin, raised without medically important antibiotics or RWMIA, and a vegetable-based diet raised without antibiotics or RWA. 1,152 were males and 1,152 were females. The birds were allotted to one of the feeding programs / gender combinations according to a 3x2 factorial design in 48 pens. Day 28 bird cecal content were harvested for colony counting using McConkey agar and chromocult coliform agar, alone or supplemented with 4 micrograms per milliliter of ceftiofur to quantify coliform, E. coli, cephalosporin-resistant coliforms, and cephalosporin-resistant E. coli. Using the Statistical Analysis Systems program, statistical analyses on bacterial numbers were conducted using the general linear mixed model procedure, and treatments and gender were used as sources of variation. Results demonstrated significant difference in the log transformed colony forming units per gram of cecal content, or CFU per gram, between feeding programs and bacterial type. In RWA specifically, the log CFU concentration of cephalosporin-resistant coliform was significantly lower in females than in males. Additionally, the lowest log CFU concentration of coliforms and E. coli were noted in females in the RWA group compared to the conventional and the RWMIA groups. From these results, gender and type of feeding program may impact resistance profiles and bacterial counts in broiler chicks. In an RWA program specifically, gender could have a significant impact on the resistance profiles in 28-day broiler ceca. So what are the next steps? What I plan to do after these results is to continue bacteriological analysis of day 42 broiler chickens, 16S rRNA sequencing for taxonomic profiling of bacterial communities as a function of feeding practices, antibiotic susceptibility testing of isolated cecal E. coli against 14 different antibiotics to identify the impact of feeding programs on antimicrobial resistance, utilizing the data from 16S, whole genome sequencing, and metagenomic sequencing to understand how feeding programs impact the beneficial microbes, pathogens, and AMR, which help guide dietary and management practices. And from that, we will use machine learning using the data from antimicrobial susceptibility testing and sequencing to develop a predictive framework that links marker genes with genome function, allowing us to develop some AMR mitigation strategies. I'd like to thank Dr. Robert Byko from Dalhousie University as a collaborator on this project, along with Dr. Elijah Chiari and Lisa Hodgins from the University of Guelph. I would also like to thank OMAFRA U of G Alliance for funding the chicken trial, And from Agriculture and Agri-Foods Canada, it would have not been possible for me to successfully continue this project without the support of Dr. Musa Diarra, my supervisor, along with Shanhua Yin, Dr. Atik Riemann, and Munene Kithama. And last but not least, I would like to thank A-Base Agriculture and Agri-Foods Canada for funding this project. Thank you.
Hi, Philip. Nice presentation. Thank you. So there is a question in the Q&A box. Did you expect a different? How do you expect the difference to impact your results?
Sorry, could you repeat that?
Sure. It's what was the difference between your control and vegetable-based diet, and how do you expect the difference to impact your results?
So yeah, primarily the vegetable-based diets typically like only used a vegetable. They include vegetable oil. The conventional and RWMIA diets used less plant protein meal, more solely animal products. Yeah, animal-based products. And I guess in regards to the results, I didn't expect it to change too much, just because it was more so we were looking more so at how the different types of like antibiotic usage towards the how the antibiotic usage would affect the antimicrobial resistance.
Thanks. Sorry. The next question is, what causes the changes in response regarding sex? It says at 28 weeks, but it would have been days of age. The hormonal changes wouldn't be that much different.
Sorry, could
so why do you think you're seeing the differences in gender?
Oh, I see. Yeah, so there could be a lot of different reasons. I think in regards to this particular date, like day 28, there have been some studies that did like you did say, like hormones don't change too much, but I believe there were other factors that they considered or that they noted that could cause some of these bacterial taxonomic CFU counts to be very different in regards to male and female. Gender is one of the more major factors that do affect various things like the gut microbiota, the microbiome, and also as well, like as we saw here, the bacterial counts as well.